Hello, my name is Colin Campbell. And the first thing I want to say, I'm really very appreciative of the opportunity of presenting again at the Lifestyle conference that's been organized by Dr. T and his colleagues. Again, I'm really delighted and thankful for that opportunity. I want to talk about, in a very general way, a topic that is obviously very important for human health and even planetary health. And it's a topic that doesn't get enough attention, at least in a positive sense, I think. It concerns dietary protein and what role it has had in the history of human health. Okay, I want to start with kind of laying some background information for why this topic is so important, which many of you, of course, already know. We have a number of existential problems in our society around the world. And I've just divided them up here arbitrarily into a couple of categories. One environmental, the other is personal health. And if you can see here, under the environmental category, there's a whole lot of very special issues that are usually considered one by one. Climate warming, depleted topsoil, loss of underground water, and so forth. And then under personal health, we've got healthcare costs, especially in places like the United States. Then also there's another issue concerning our deep dependence on prescription drugs, quite frankly. And then we have high mortality rates for diseases like heart disease, cancer, and so forth. So in any case, we've got all these topics, and this is just a mere small number of topics in each of these general categories. It's even a bigger general category, you could say. So all I'm trying to do is to tell this story to illustrate a point. Namely, each of these topics tend to gather their own workers and own people to work on problems in a sense. And it suggests that each of these problems have independent causes. That's what a lot of us tend to think. I would suggest that's not quite the best way to think about it, because I'm suggesting that instead of each having its own characteristics, which they do, of course, but instead of just focus on that, I want to think about it in a larger context. That is to say, there is, quite frankly, one independent cause. Guess what? And I'm going to say, it is the food we eat. And we need to really know better. Why do we eat the food we do now, and how we might make it better? So this is the topic of my conversation. How do we make it better in consideration of what we're now doing? And I'm going to turn your attention to animal protein, because it's as you'll see in a moment, it's a single nutrient, of course, in one sense, but it has actually been a very important nutrient in terms of the evolution of health in different countries around the world over time. Here, what I'm showing is that one interesting relationship between the amount of protein being consumed, if you can see on the y-axis, the amount of protein consumed in different countries versus income. Wow, straight line relationship, really interesting. It really suggests something that I'm sure many know, but it is an impressive relationship. The more money that people have, the more likely they're going to be consuming animal protein, because animal protein has some special value, so it's said. And that's been that way for years, decades, even centuries. Well, as people get more money, then they want to gravitate into making sure they get enough animal protein. So I've been in this business for now more than 60 years, 66 to be exact, professionally. And I've seen there's a lot of complexity in this issue, both on a societal level, economic level, you name it. But it's particularly complicated when it comes to questions of biology or the basic science. And so we get caught up in all these details and get confused. I'm going to suggest, at least for me, having been in this field for so long, I've narrowed down my thoughts to two specific recommendations. Consume plants, not animals, that's simple. Secondly, consume food in the whole food form as much as possible, or as I say, in a way that simultaneously offers all its nutrients to the body, more or less at the same time, because the body is always choosing how to break down food, what nutrients to use, and so forth and so on, which you'll see. So consume plants, consume it in the whole food form. Incidentally, we should remember too that when we consume more animal food, to get that protein, if you will, or we consume less plant food. It's like a seesaw situation. More animal food, less plant food, or vice versa. And as we consume more animal food and suffer its consequences, we also suffer consequences by less plant food. That's a given, but sometimes we tend to forget that. Now, in terms of eating animal food, I would suggest that there's one nutrient that has had more influence on our decision to consume animal food than any other. Animal-based protein. Animal-based protein. I call it the driver nutrient. And what's interesting about this, it almost has become almost like a religion for some people, very strongly felt belief system. Anyone questioning the consumption of animal-based protein, which has happened off and on over the last 175 years, anyone really daring to question the consumption of animal-based protein in the professions especially, they have risked the possibility of losing their careers. It is so contentious, and so many people believe so strongly in it. They'll say anything to try to get us to eat animal protein. And I am one who is challenging that idea. That's the subject of my talk. One other part of this question, too, is we all have, around the world, we thought of animal food as being very important, as I say, on the one hand, because we want to get this high consumption of animal protein because it's said to be high quality. Plant protein is said to be low quality, if you know that idea. It's said to be high quality. And so it's led to, not factory farms, but it's led to these enormous big factory operations, industrial operations, just basically producing animals by the billions. We kill something like 2 billion animals a day around the world. It's really quite incredible. And so what's really interesting about this time is that we don't tend to know how serious this problem is. In fact, what we tend to talk about too often, you can see it on the internet, is how are we going to meet the demand for more in the future? I find that a little troubling. But that's the topic of the day. How can we get more animal food? I want to address that question first. But first, I want to tell you a little bit about my own background in this, because it is germane to some of the views I had. I started out on the farm milking cows, where we produced animal protein, milk, meat, and eggs. That's the way I grew up. Went away to graduate school to do a doctoral dissertation, actually on the subject of advancing the consumption of more animal protein. That was 1962. Then shortly thereafter, a couple of years or so, I was in academia. I was put in charge of a program in the Philippines feeding malnourished children. And there, not just myself, but in the nutrition community in general, it was believed that malnourished children in poor countries around the world were in that condition because they didn't get enough protein, especially animal protein. So our charge at the beginning of that project, which was funded by our U.S. State Department, the idea was, how do we get these kids in the Philippines who are suffering more animal protein? And so that was consistent with my personal background, my doctoral dissertation, and there it again. Animal protein, basically. But then I saw something too. My colleagues in the Philippines suggested that the few children getting the most protein, not many, few, they seem to have a higher risk for liver cancer. And I saw that evidence too, to some extent. But then this report came out in 1968 from India, an experimental animal study, where they believe too that animal protein could actually protect against forming liver cancer. As I say, this is an experimental animal study. They did this study by one group having 20% of total calories of protein. That's pretty high level. The other group, 5%, okay? And what they saw was exactly the opposite of what they thought. In other words, the animals getting a higher level of protein, they're the ones who got, 100% of them got the cancer from that starting point. Animals consumed at 5% did not, 0%. Amazing. I mean, now, my thoughts is, what's going on here? This is pretty striking. So that was actually the beginning of my career. Increasing protein, increasing cancer. That was so provocative. I couldn't believe it. None of my colleagues really could believe it. But I then got some funding that lasted for many years thereafter, generous funding, to study this question. Is it true that animal protein has an ability to turn cancer? So we started out in an experimental animal study to do that work. Here's a presentation of the growth of cancer over just the first 12 weeks, okay? And during that time, the cancer is started by a gene mutation, if you will. So let's look and see what happens here. Animals had 20% protein. They got the cancer, as you can see, quite well in the first 12 weeks. Animals fed 5% did not. There it was. That was a repeat, almost essentially what the Indian workers had done. The animal protein effect on cancer, experimental cancer in this case, one kind of cancer in laboratory animals, that's rats, there we saw this amazing difference. Then we did something else. By the way, I keep have to remind myself and you folks, I didn't believe a lot of this. So I was trying to deal with it in a way and, say, wait, that's not quite right. What we learned that we could actually turn cancer on and off. 20% protein, 5% off, on, off. That was dramatic. When I saw that amongst many other observations in this journey, I saw that, I said, there's something here. I mean, this is pretty amazing that we can change cancer development just by adjusting the protein level. It led to a challenge, a big idea, by the way, namely, what it did, it led to the general proposition that it's nutrition rather than the genes that start the cancer, if nutrition that really controls cancer development. Incidentally, the protein we were using, the protein that the Indian workers were using was casein. That's the main protein in cow's milk, an animal protein, but as we subsequently learned, I should add at this point, it's animal protein in general. The casein is merely a good representative, so it turns on cancer. In contrast, and after some years, we actually also had a look at a couple of plant proteins. They did not increase precancer development, even when they're fed at 20%. So there was a striking difference between casein on one hand and soy protein on the other. The animal protein turned on cancer, pure and simple. Okay? But then, I kind of suggested an obvious next question. If it does that to cancer, what about other diseases, like heart disease, diabetes, so forth? And if animal protein turns on diseases, what do plant proteins do? And yes, I'm just sharing with you my thinking as time was passing. But given what we saw at that point in time, it's hard to accept in a sense. I really had to, as anyone would in this area of research, I wanted to know what was the mechanism by which this occurred. Because if we could understand the mechanism, maybe some kind of biochemical mechanism, if we could understand that, then maybe we could develop a drug and block it. So we could keep on consuming our animal protein, if you will, and just take a drug on a regular basis and just solve problems that way. So here's what we did over a period of, 12 and 15 years, I think, something like that. I was fortunate to have a lot of graduate students under my direction, working usually on their PhD dissertations. And so each one of these tests of a possible mechanism was usually a PhD thesis. So here's the way we study cancer experimentally. It's divided into three phases. Starts out with an initiation phase, which is the phase during which the mutation occurs, the cancer starts growing. The second phase has to do with the cancer, new cancer cells that are created from the initiation, then growing and dividing, and growing and expanding, eventually into a tumor tissue. And thirdly, that tumor tissue from the origin will tend to spread to other tissues. That's metastasis. So we got three phases, more or less, just arbitrarily. We got three phases in research and studying cancer: initiation, promotion, and progression. Okay? So we started to look to see what if this mechanism that I was hunting for might start right here in the very beginning. So we looked at a bunch of different mechanisms, if you will, with the high protein. Animals had the high protein diet increased the amount of carcinogen getting into the cell. That was a big thing. It increased the amount of carcinogen getting into the cell. So, oh, that's it. We could just block that, maybe we're home free. But we kept on looking. It also increased an enzyme that synthesizes, an enzyme that actually activates the carcinogen, the create a product that binds the DNA, the genes, if you will. So the high protein that increased the enzyme. In addition, it increased the amount of carcinogen in the cell. Then thirdly, the animal protein altered the structure of that enzyme. That's called mixed function oxidase. It altered the structure in such a way that the ulcer structure actually also would increase the metabolism of the carcinogen to create this very reactive product. That product in turn then binds the DNA. That's the start of the mutation. That's how it happens. Carcinogens come into our cell, they're metabolized, and some of the products they create are very reactive chemically, and they combine to DNA. That's the start of the mutation. Now, we have normally in our system that works really well, millions of times more so than not. It works by repairing this DNA damage. That's what we have in we have a system. So that goes on all the time. We've got this DNA repair mechanism. Guess what? That's a good thing. The animal protein actually decreased this. That's a good thing we have. It increased all these, decreased that. And then in the second stage, promotion, notice that we're going, this is reversible, I'm suggesting here, based on the last slide I just showed you. And what we see there is, once again, a bunch of different methods. We kept looking at it. It was hard to really sort of decide, if you will, which mechanism do we actually focus on to find ways to block it, if you will. And so here's what, in summary, we saw. The high protein diet increased 8 cancer mechanisms that actually promote cancer, when it should be the opposite. The high protein diet is increasing all those enzymes and sucrose and so on that promotes cancer. And the 2 mechanisms we have to prevent us from getting cancer that nature provided to us, the high protein diet actually decreased them. So what do we have? We have 10 mechanisms, and it turns out all 10, there were no exceptions, all 10. I'm sure there's probably another 100 or 200, but whatever, in this period of time we had available to ourselves. I found it quite amazing. So of the 10 that we thought there might be a good mechanism to create a drug for, they all did the same thing. They seemed to work in unison. That was an exciting idea. And then finally, I came to this opinion after about 15, 20 years, something like that. It was clear that there is no such thing as the mechanism. There's a whole bunch of mechanisms all working together. That was really quite amazing, I thought. And so we don't have a mechanism to actually develop a drug to block it. I mean, which one of the mechanisms are we going to block, or the other 100 or 200, whatever it is? So it really suggests that the whole idea of using drugs to solve problems is really highly questionable. When in fact nutrition, and just one nutrient in this case, one nutrient, creating all these mechanisms to work together in unison to create that response. Now, so that one to me was very impressive. But what it basically showed is that the high protein diet works. It's called biologically plausible. If there's no doubt about that. Here's another way of looking at the consumption of high animal protein. And here I'm going to show you some plots of studies done during the last 70 years by various authors. I actually knew most of these people, I think all of them actually. And I went back into the literature recently and looked at some of the results that they were producing in those days. And here's what I found. On a question concerning kidney cancer, it turns out that the higher the consumption of animal protein along this axis here, the higher the rate of kidney cancer. And well, these are compared to a bunch of different countries. And it turns out it's a very straight line relationship. It's really incredible. I drew that line on there. They didn't have it. They didn't think of it that way, but I drew a line on there just as simply putting, the various points on both sides of the line. It's obviously not perfectly accurate, but that's beside the point. It is a straight line relationship between protein consumption and kidney cancer. Wow, kidney cancer. And it comes right down here to near the XY origin. Here's another one. This is heart disease deaths. That's more. This study was done in 1959. As the percent of animal protein increases along the x-axis, the amount of heart disease deaths increases too. And you can see here, this is pretty amazing too. It's almost the same thing we saw with kidney cancer, heart disease, kidney cancer, both with animal protein. And then there's been a bunch of other studies done over the years that have been, were not known to the researchers, and they kind of misrepresentatives to some extent, in my view. Here's a relationship between consumption low-fat milk, dairy, low-fat milk, and prostate cancer. And what they found is an increase in consumption of low-fat milk, which is nothing more than protein, basically. The higher the intake of that product, the greater the risk for prostate cancer. Now, the conclusion from this at that time was, oh, skim milk is not good for us. Okay, but in reality, there's a bigger story here. The low-fat milk is actually a protein drink. It's an animal protein drink, just like these other two. Here's one for breast cancer. In this case, this was a friend of mine back in the 1970s and 80s from Canada, who was studying the relationship between the consumption of saturated fat, which was said to be bad, and breast cancer. It's what you see here once again, this straight line relationship for all the different countries. The higher the saturated fat intake, the more breast cancer. Now, saturated fat, as you may know, is primarily only present in animal foods. So in a sense, that's just really representing animal protein too, you could argue. Then there's one here, really, this is significant too. Here's the relationship between consumption of cholesterol on the x-axis or y-axis versus heart disease deaths. It's another study compared to the other one. So anyhow, we have the highest death rate and the highest, consumption of the highest intake of cholesterol. Now, cholesterol is only present in animal food. So once again, the higher the consumption of cholesterol, right, from animal foods, there's a straight line relationship once again with respect to heart disease. That's pretty impressive. Here's one for meat consumption and colon cancer. There's one for uterine cancer. And uterine cancer, and in this particular case, is total fat. Total fat in international studies is highly correlated with animal protein consumption. So once again, it's the animal protein phenomenon. So what happened was that when you consider all these studies together, let's say this is not the results. This is not the finding of the interpretations, I should say, of the authors done in the last 50, 75 years. But it turns out that each one of these plots are linear in the relationship, and they all represent one thing, animal protein. And so I would argue that cholesterol intake, meat intake, total fat, low-fat milk, and saturated fat, they're all surrogates or substitutes, if you will, for animal protein intake. Now, here's one here from my old friend in Canada, where he did the one with saturated fat from animals, the straight line relationship. Here he's looking at plant fat, which is unsaturated fat. I label it plant protein. You see no relationship. So here is something really interesting, in that it's the animal foods, as they are increased, we see each of these diseases having this amazing increase, starting from zero level. Starting from zero level, see increased risk at that point. Now, that's just a very brief description of some of my laboratory research, and of course, in addition to the research of others. So then I had an opportunity in the early 1980s to meet with some Chinese colleagues. This is when our two countries were finally getting together, talking to each other again. And one of the senior people, a senior group from China that came to the United States, also included a very well-known Chinese scientist, Dr. Chen. He came to the United States and he wanted to stop by and see me to be interested at Cornell. And I said, sure, by all means. So Dr. Chen came to visit my lab. He stayed for about 8 months and did some research too. But in any case, he told me about a study that he knew of that was actually being popularized on United States television. It was a study that had been released by the Chinese government in about 1981. It was an atlas of cancer mortality. And Dr. Chen knew the senior editor of this, Dr. Li Junyao, at the Cancer Institute in China. So it just so happened Dr. Li was in the United States too at that time. So I called him up to Cornell. We all got together, Chen and Li and I, and started to say, well, first off, I should tell you, this when I say atlas, what this really shows in the inside of this book was that for each of it, about a dozen different cancers, they tend to be distributed in certain areas of China, much higher in some regions than in other regions, right? But it's really very impressive. And the same thing for total cancer. You see that. And they had that for about 12 different cancers. I got the idea at that point in time because this was a huge study in China, 2,500 counties, even an 80 million population. What that suggested is that cancer is a local disease geographically. Why don't we do a study? Well, why don't we collect information on diet and nutrition and a few other things, but to see why cancer is so high in some areas and not in others? That's what led to the China study. And I should add, that was a very fortunate opportunity to do that. Dr. Chen and I were the colleagues. Because I had been doing the work in the laboratory, here was a human population we could test some of these ideas. So the stuff I learned in the laboratory with laboratory animals, when combined with the human experience, was a great opportunity to get more information that was extraordinarily valuable. Incidentally, the three of us, Dr. Chen, Dr. Lee, and myself, we added one more person, senior investigator, really the best known biostatistician in the world, as far as I'm concerned, Sir Richard Peto at the University of Oxford in England. So it was actually four of us who led the study. And then we had a number of people at the same time. With Dr. Chen had an enormous variety of provincial health teams working in various parts of China who were able to go out into the country and organize this study that we got money for, to organize this study to collect information to see what we might learn. That was funded by, cash, it was funded by the United States, a little bit by the United Kingdom, but the big contribution in terms of labor was, of course, China and Dr. Chen and his marvelous team. So it was a great project between, as I say, United States, England, and China. And this was, by the way, the first research project between the United States and China. It started in 1983. It finally was published in 1990. And then 1997, I'm happy to say, I'm proud to say, that the Chinese government had determined, or they had a contest to see which was the most productive research project in medicine for the 20-year period following the passing of Zhou Enlai, the Prime Minister of China. During that 20-year period, there was about 111 entries in this area. Now it's got first place as the top medical project in China during that 20-year period between 1978 to 1997. But it was not only valuable for China, it turned out, I just found it extraordinarily good, because it gave me the opportunity at least to see whether we learned in the laboratory was consistent with what we might see in humans. I mean, I can't emphasize how significant that really turned out to be. There's the publication itself. It's about almost 900 pages, very detailed data, enormous amount of collection. As I say, it's Shedra Shun, myself, Dr. Li Yao, and Richard Peto. I want to show you a couple of things what that China study did for us. And this has to do with serum cholesterol as it relates to heart disease. And so it's comparing, in a sense, real China with the United States. Heart disease, real China, United States. So here, let me show you the first part of this. At that time, this was about 1990, when we finished up with some of the data collection. It turns out the range of cholesterol intake, the range of serum cholesterol versus heart disease in the United States, that was about 360,000 people. It was a very huge number of people. The relationship between heart disease and serum cholesterol is almost a straight line relationship. The higher the serum cholesterol, the higher the heart disease. Of course, that, as you know, has been a very popular, accepted idea around the world. More serum cholesterol, more heart disease, okay? And there's the mean for the United States. Notice here, the range in the United States is 155 to 274. This is the low end, this is the high end. The midpoint was about 212 or so. So that was a US thing. Incidentally, at that time, just prior to that, some of the recommendations of the United States in the heart disease community was don't go below 150 because there's some evidence that colon cancer can be increased or suicides, actually, of all things. So this is basically uncertainty right there. So what did the China study say? Here's something I consider to be quite extraordinary. It turned out the serum cholesterol in China, rural China, was 94 to 162. Notice that 162 is near the low. That's near their high. These are county means, by the way. The mean up at 226, I mean 126, 126 to 212, okay? What it showed is that this line here, where in the West, we didn't know what it was going to go to. We thought maybe we'd go down here or increase risk for other disease and so forth. People weren't supposed to get more than 150. Well, in world China, we showed that the higher, that in this really low range of cholesterol, serum cholesterol, the higher was the risk for the Western kind of diseases like heart disease and cancer and so forth. It was highly significant. So, in effect, what the China study did, it just added, it extended this line and clarified some confusion. No, it's not true that as cholesterol is decreased, suddenly it's going to drop here and cause problems. No, it's not doing it at all. It shows that in rural China, it keeps on going down, 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 down like that. And in fact, in China, in the area where the least heart disease was, I think it was something like 1 out of 250,000 death certificates in a row, only one was heart disease. In other words, heart disease is non-existent in certain areas of China, virtually, at least in those early years. This combination of data here was very exciting because it showed something going on. In other words, how does this keep going lower, lower, lower like that? Well, you could guess that it goes lower because more and more plants are consumed, less and less animal protein. Okay, now let me turn your attention to something more recent, especially in a couple of different ways that having to do with the coronavirus. In this case, the China study that we did in 1983, finished up in 1990, that study was repeated a second time in 1989, which included both mainland China and also Taiwan, I should add. Nice cooperative agreement between those two areas of the world. So it was from that second study that we got some data on this, and that was made available also in the early 1990s. It has to do with hepatitis B virus. Hepatitis B virus, as many will know in the audience in China, is a serious virus. It causes liver cancer. And liver cancer is a serious disease. There's said to be about 800,000 deaths worldwide in liver cancer. That's really high. So here's a serious virus. And so we had a chance to measure this virus in China as a function of liver cancer. Now, I'm just schematically, here's what we're talking about. The virus is out there in the community, and this antigen, this is an active virus. When it comes in and lands in our bodies, it's saying there it is, it's active. We test positive. We don't yet see symptoms. So at that point in time, the virus has two paths that may follow. One is to form liver cancer. That's the symptoms. And death, I should say. The other is that the virus, once it lands in us, antibodies can form against it. Okay, this is a bad route here. It's a good route. So I collected this data and I wrote it up. That was subsequently published. Well, by the way, yes, we had a lot of nutritional factors. You give us some information. Why does the virus go that way in this case or this way? And we had nutritional factors to look into that question. Let me show you what we found. Okay, as I said, 800,000 deaths worldwide makes it a serious virus problem. That paper was published, and the report that I did was in early 1990, early in 2021, about a year and a half ago. So here I want to summarize to you what we found. It has to do with the prevalence of hepatitis B virus in 1989, and that almost 9,000 adults who rural China. It was actually rural China in this case. So in any case, here schematically, again, is what we found. I mean, a virus is out there, it infects us. Once it gets into our body, it's an antigen. Okay, it's a protein that's part of the virus. So this floats around our body, as I said before, can lead to liver cancer, okay? It turns out, even a small intake of animal food leads to liver cancer, a small amount. This is highly, highly significant. I'll show you the statistical significance significance of this moment. So people who get the virus, if they're eating animal food, problems could be a much higher risk of liver cancer and death. In contrast, people in rural China, or no, this is, well, mostly rural China, but in any case, people consume more plant food when they get this virus. Here's what happens to those folks. Antibodies form, inactive virus. So people consuming plant food, the virus is not too much concern. It's certainly not going on and causing serious disease like liver cancer. And it turns out, so people eating a little animal food, the other ones get the liver cancer. They're the ones activating the virus. People consume more plant foods. In contrast, they form antibodies and do not get the liver cancer. Striking difference, striking difference. In fact, there's multiple ways for us to look at that question. There are altogether a total of 11 risk factor correlations, all significant and very highly probable level of 0.001. 11 risk factors all show the same thing. All this correlation converges the same outcome to give us this conclusion here. Animal food causes liver cancer, even though people may be infected with hepatitis virus. Plant food, in turn, has sort of the opposite effect. It allows antibodies to form. And of course, given a reference here of that study, this is the second China study. And I took this information here and wrote it up for publication at the early part of the pandemic, because I think this is kind of interesting. Nutrition can have an effect on viruses like it does on heart disease, like it does on cancer, like it does on diabetes. This is what it's saying. The effect of nutrition in this case is the same as it is on other diseases. And the effect is dramatic. It is truly dramatic. And so I wrote the study up and I just put at the title, I should say, what the results were in hepatitis B virus, but I added another comment in the title. COVID-19, for a question mark. I'm just really suggesting, that's what we do in science. I'm really suggesting that people eat a plant-based diet, stay with it, stay away from animal food. They're not likely to suffer the consequences of the virus if it applies to COVID-19. A short while later, after this year, by the way, I published, 375 publications in peer-reviewed journals, more or less around the world, different the leading journals. I sent this into 2 leading journals. Most of them would not even review the grant, would not even review the publication. I'm just simply saying that because this is a message for the entire world as far as I'm concerned. When science is going wrong, not even to consider, there's something like this, that nutrition can be important to maintain overall health, which includes viral infections. Something's wrong. Something is deadly wrong. And so I did want to point that out because here we got these results. There's no mistaking about it. People eating a little animal food, they get liver cancer from if they get infected with the virus. People consuming don't get that, but they didn't get the liver cancer really, because they certainly don't suffer the consequences when consuming bad food. And sure enough, a little bit later, that was published a year and a half ago. Then in the next 6 or 8 months or something, 2 more studies. I understand there's a third one, but I haven't seen the results of that one. 2 more studies that were focused on just questionnaires, asking people who get the coronavirus symptoms. They were asking questions, how did it turn out? Just usual simple questions. Not very strong paper, but well done. They both showed that people who consume more plant-based diets, their risk of getting the serious consequences of the coronavirus is greatly decreased. The same thing, what I was suggesting in the hepatitis paper. Now, let me summarize this a little bit more. In COVID-19, there's a scheme. You'll see that nutrition, poor nutrition, that's the Western kind of, this is an animal food-based diet, if you will. They are the people who have comorbid conditions, heart disease, diabetes, cancer, and so forth. And we all know now that the vast majority of people who suffer like serious consequences of COVID disease are people who have already been diagnosed with heart disease, diabetes, cancer, obesity, and so forth. In other words, the people who have these comorbid conditions that give rise to the severity of the disease, these diseases can be prevented by a plant-based diet, a whole food plant-based diet, okay? That's where this is coming from. So if people ate the whole food plant-based diet, they don't have the comorbid conditions that sets them up for disease severity, number one. And number two, we have data now. I suggest have a lot of confidence. If people consume a whole food plant-based diet, they're not going to get the severity of a viral disease, whether it's COVID, whether it's hepatitis B virus, or other viruses. I can find evidence for that too. So when you're consuming this kind of diet, as a life practice, no animal protein, no animal food, you don't get the comorbid condition that's greatly reduced. We already know that from lots of data. And then you're not sensitive to the possibility of what the disease severity from the COVID virus in this case. So here's my suggestion: whole food plant-based diet. These subsequent two studies I just mentioned, they're called plant-based and pescatarian. Not very perfect, but nonetheless, they saw a 73% decrease in those who consume a plant-based and pescatarian diet. That's pretty substantial. That's pretty substantial. Even when the diets they're consuming are just questionnaires and kind of imperfect measurement of dietary practices, but nonetheless, with that kind of significant decrease, it supports what I said here in hepatitis virus. And that's these two studies, and two of those studies are shown here, and together with the publication of my own just prior to these, is a combination study showing nutrition, the importance of nutrition to prevent so-called Western diseases, heart disease, and so forth. And in addition to basically presenting us with the possibility of remaining resistant. That's how we get immunity. We consume this kind of diet, our immune system is greatly enhanced, and we're in a much better position to not get these kind of diseases. That's simple. So I want to finish off then, and just let's show you here quickly. We've got an online course at Cornell University that I've put together involving a number of different faculty. If anyone is interested, it's at nutritionstudies.org. But what I want to say is this. You know, your conference is focused on lifestyle medicine, great concept, of course. That idea is going around the world. But when we really look at the data regarding lifestyle medicine, what we see, the main contributor to good lifestyle practice, if you will, eating the right food. Eating the right food. I know lifestyle medicine includes obviously information, exercise, and stress, and a few other things like that. They're all important, very clearly. But the major effect on personal health is the food we eat. The food we eat should be plant-based in the whole food form. That's a huge, huge, difficult story for many people in the world. It is the central component of lifestyle medicine. It is the central component. Unfortunately, in lifestyle medicine, this evolution of these kind of programs around the world are not, in my view, given nearly enough attention to nutrition, because the medical establishment has never given much attention to nutrition. And the extent to which it even is discussed or considered is basically a very poor version of lifestyle medicine. To me, a very poor version of diet or of nutrition. So the real nutrition that has the really major effect is the nutrition that where we're consuming as close as possible to plants only, as much as possible, the whole food form. There is a secret. It's almost a secret, but that is the solution to, in my view, we go a long way, I should say, to reducing human disease. And thereby, insofar as it's possible, when we eat more of that kind of food, we don't need the lifestyle that causes all the environmental problems. So we get 2 for 1, if not 4 for 1, 5 for 1 for other consideration. Eat more plant-based, whole food plant-based. It's amazing. The effect is amazing. Our research started out with experimental animals, and then involved human studies. And there's many ways I can tell this story, especially in the policy arena where I've been very much involved. It is the biggest secret there is, in my view, in the world. We call it lifestyle medicine. I don't, quite frankly, I'm not as enthusiastic for that term as many may be, because It's a kind of a substitute for preventive medicine, which never did well in medicine. I would like to suggest put the focus on nutrition and make that a major part of the lifestyle medicine equation. Again, many, many thanks to Dr. Shi and his group. I really appreciate this. I think that this is the third year I've been involved with making this presentation. I'm just so delighted. I spent, I think I was in China somewhere between 20 and 25 times for over a period of about 20 years. I just loved the opportunity of being able to work with my Chinese colleagues. I had many senior Chinese who visit in the laboratory. We really, China is my second country, let's leave it that way. And so I just thought this collaboration that we entered into with England, in this case with Sir Richard Peter at the University of Oxford, it was amazing. And so I can't thank enough the organizers of this conference and giving me a chance to tell this story. Again, best wishes and thank you.